4. Unit rate as the constant of proportionality. Points to remember. Proportional relationships have a constant ratio or unit rate. The constant ratio or unit rate can also be called the constant of proportionality. So for example 1, National Forest deer population in danger. Wildlife conservationists are concerned that the deer population might not be consistent across the national forest. The scientists found that there are 144 deer in a 16 square mile area of the forest. In another part of the forest, conservationists counted 117 deer in a 13 square mile area. Yet a third conservationist counted 216 deer in a 24 square mile plot of the forest. Do conservationists need to be worried? What is the population density of deer per square mile? So what they want to know is per square mile. So we have mile over deer, or deer over mile, sorry. So the information that we need is 144 deer over a 16 square mile. We also need 117 deer in a 13 square mile and 216 deer in a 24 square mile. So the numbers that we need are 144 over 16. We also need the 117 over 13, and we also need 216 over 24. When we divide each of these will give us 9. That being said, remember when we divide this, that's going to give us our unit rate for 1 square mile. So the next statement says the unit rate of deer per 1 square mile is, and in this case, 9. So the constant of proportionality, which is the same as unit rate, is then going to be 9 over 1, which equals 9. The next question says to explain the meaning of the constant of proportionality in this problem. That means for this particular problem, there are 9 deer for every 1 square mile of forest. Then it says write the equation to represent this relationship. Well, to do that, remember our general equation is y equals kx. All we have to do is replace k, because that is our constant of proportionality, with what our number is. Well, in this particular case, our constant of proportionality is 9. So I'm going to replace k with 9. So y equals 9x. That is our equation. So next question for this particular problem says, use the unit rate of deer per square mile, or y over x, to determine how many deer there are for every 207 square miles. Well, in order to do that, our unit rate is 9. So if I multiply 207 times 9, because remember there's 207 square miles, and 9 times 207, that means that there are 1,863 deer and 207 square miles. Because remember, it's 9 deer for every square mile. So it says use the unit rate to determine the number of square miles in which you would find 486 deer. Now remember, if it's 9 deer for every square mile, in this case, we want to divide to find out how many square miles for that many deer. So I'm going to take, let me bring that down. I'm going to take 486 deer and divide that by 9. When I do that, I get 54. So that means for that many deer, that's going to cover 54 square miles. Okay. So now let's look at our vocabulary. Our vocabulary, a variable is a symbol, and I'm going to scratch it. I'm going to highlight this because I think it's very important. A variable, okay, is a symbol such as a letter that is a placeholder for a number. A proportional relationship, okay, a proportional relationship is described by a set of ordered pairs like x comma y that satisfies the equation for some number, and then is called the constant of proportionality. In other words, we can make it a unit rate. That is the number that describes the multiplicative relationship between the measures and of the two types of quantities. The pairs represent all the pairs of numbers that make the equation true. In the given situation, it would be reasonable to assign any variable as a placeholder for the given measures. For example, a set of ordered pairs would be all of the points that satisfy the equation. Where is the constant of proportionality? This value for specifies a number for the given situation. In other words, all that basically means is we have our equation and we can keep putting in numbers that will make that equation true. Okay? So example number 2. Example number 2 says, Brandon came home from school and informed his mother that he had volunteered to make cookies for his entire grade level. He needs 3 cookies for each of the 96 students in 7th grade. Unfortunately, he needs the cookies the very next day. Brandon and his mother determined that they can fit 36 cookies on 2 cookie sheets. Is the number of cookies proportional to the number of cookie sheets used in baking? Create a table that shows data for the number of sheets needed for the total number of cookies baked. Well, let's make that table first. So here's what we can do. I know I do not draw straight lines, so apologize right there. Well, we need 2 sides. So we need our cookie sheets here on this side and our cookies on this side. And how did I determine that? This is my X value, this is my Y value. Remember, independent and dependent. I can have cookie sheets and not do anything with them, but I can't have cookies and not be able to I can't put cookies without a cookie sheet. So the next thing I'm going to do is I'm going to make lines here. I may not use them all, but I'm going to put them there. So the first thing I'm going to look at is I know I can put 36 cookies on 2 cookie sheets. And I'm going to put that on the second line because the first line I'm going to use for my unit rate. The next thing I have to do is figure out how many cookies I need in total. Now, the reason I'm underlining this is because I need 3 cookies for each of his 96 students. So I need to multiply 96 times 3. So 6 times 3 is 18. 9 times 3 is 27, plus 1 is 28. So in total, I need 288 cookies. So to find my unit rate, I'm going to take the 36, divide it by 2, and the reason I'm doing that is y over x. When I do that, I get 18 over 1, which is my unit rate, which is also my first row. For 1 cookie sheet, I can make 18 cookies. So for 4 cookie sheets, I can make 72 cookies. For 6 cookie sheets, I can make 108 cookies. For 8 cookie sheets, I can make 144 cookies. And if I double that, I'm looking at that saying, if I double 144, I get 288, which is how many cookies I need. So if I multiply that by 2, I can multiply the 8 by 2 and get 16. So 16 cookie sheets would give me 288 cookies. So my unit rate, y over x, which is what we did up here, is 18, which means my constant of proportionality is 18 over 1, which equals 18. So to explain the meaning of the constant of proportionality in this problem is 18 cookies for every 1 cookie sheet. Now it says, write the equation that represents this relationship. Well, remember, our general equation is that y equals kx. You don't have to keep writing that. You can just write the equation. So I'm going to take out this k, and I'm going to put in my constant of proportionality, which in this case is 18. So this is my equation. So now it says it takes 2 hours to bake 8 sheets of cookies. If Brandon and his mother begin at 4 p.m., when will they finish baking cookies? Well, if they start at 4 p.m., and it takes 2 hours to bake 8 sheets, by 6 o'clock, oops, sorry, let me erase that. By 6 o'clock, they can make 8 sheets of cookies, which if we look up at our table, that's 144 cookies. So from 6 to 8, that's another 2 hours. That's another 144 cookies. And I add them together. That's 288. So they want to know, when will they finish baking the cookies? Well, they will finish at 8 o'clock. Okay. So next, our last example 3, our French class cooking. Suzette and Margot want to prepare crepes for all of the students in their French class. A recipe makes 20 crepes, and I'm going to underline that as we go along, with a certain amount of flour, milk, and 2 eggs. So we need a certain amount of flour, milk, and 2 eggs. The girls already know that they have plenty of flour and milk to make 50 crepes, so we got to make 50 crepes. But they need to determine the number of eggs they will need for the recipe because they were not sure they have enough. Consider the amount of eggs necessary to make crepes. What is the constant of proportionality? Well, notice what it says up here. A recipe makes 20 crepes with 2 eggs. So, eggs and crepes. Because we need to know the number of eggs that they will need. But we need to know how much 1 egg is, how many crepes makes 1 egg, or 1 egg makes how many crepes. So we have 20 crepes over 2, and that is 10 over 1, or 10. So our constant of proportionality is 10. And it says, what does the constant of proportionality mean in the context of the problem? What that means is they can make 10 crepes with 1 egg. So now it says how many eggs are needed to make 50 crepes? Well, 50 crepes then divided by 10 crepes. They would need 5 eggs. So now to sum it up, it says, what is another name for the constant that relates measures of 2 quantities? Well, that is proportional relationship. And it says, how is the constant of proportionality related to the unit rate? Well, they are the same. So to sum it all up, if a proportional relationship is described by the set of ordered pairs, x and y, which we are going to use that throughout the entire unit, that satisfies our general equation for our constant of proportionality k, then that is what it's called. And that ends our lesson for today.